I'm Kirk Harnack. On This Week in Radio Tech, I'm joined by Chris Tarr, Chris Tobin, and our guest, Mark Persons. We're talking about troubleshooting and repair of broadcast equipment. Great tips and great techniques are ahead. Twert is up next.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Radio Tech is brought to you by Cachefly at CACHEFLY.com.
This is This Week in Radio Tech, episode 93, recorded August 3rd, 2011. Benchwork. This Week in Radio Tech is brought to you by Telos Systems and the new HX1 and HX2 telephone hybrids. On the web at telos-systems.com/HX. It's time for This Week in Radio Tech. Hello there. I'm Kirk Harnack, and very glad that you've joined us. This is the show where we talk about radio technology. You know, that includes a lot of stuff. Everything from the microphone to the audio console to the, the needle on the turntable, if they're still using those, cart machines, cassette decks, a lot of computer playback type of gear, compact disc players. Some people still use those. And everything all the way out to the transmitter and the antenna and getting the signal all the way to the listener. And now we're dealing with lots of other technology. So, like internet and some satellite radio. Sometimes we've been able to talk about that and the technology there. So we're talking about a lot of things here. And let's bring in the co-host and see if we get more of it discussed today. First of all, from Manhattan, the best-dressed engineer in radio, let's say hi to Chris Tobin. Hello, Chris.
Hello, Kirk, and hello, everyone. I'm a broadcast technologist with the folks here at CBS Radio New York with 6 radio stations, 3 AM, 3 FM, and having a good time using technology, making money, and doing radio.
You guys are making money. That's good to hear.
Yes, I just read somewhere our fourth quarter 2010 was 4% up. We're good.
Awesome. Okay. Well, let's swing out to Muckwonago, Wisconsin, and see if Chris Tarr is making any money. Hi, Chris.
Hello there. As a matter of fact, I am certainly making money. I had 18 days, and within that 18 days, successfully launched a regional radio network with a syndicated show that we just actually launched on Monday. So some of the things I do as Director of Engineering for Intercom's radio stations in Milwaukee and Madison, Wisconsin.
Well, very cool. Thanks for being with us. And we're bringing in a guest we've had before, and at some point we may consider him just a regular co-host. I want to say hi to Mark Persons from Brainerd, Minnesota, and his company is MW Persons and Associates. Hey, Mark, are you there?
Hi, Kirk.
Hey, yeah.
Always good to talk to you. You're a fun guy to be around, by the way.
Oh well, tell my wife and my kid. Tell my 1-year-old kid. Mark, we're glad to have you with us. You've been a contract engineer for a long time, and we're not going to get into it just yet, but tell me what we're going to get into talking about when we pick up your topic here in a few minutes.
Well, I think we're going to talk about troubleshooting electronic equipment on the bench. But, there's a whole story that goes with that, and I really have to tell it from the beginning. So where do we start? In the beginning, I guess, huh?
Sure. Okay. Let's go right ahead and jump into it. I'll just start by mentioning that you have been what we call a contract engineer. You work for a lot of different radio stations in your career, and you've done things like design audio gear for Zircom. You've written a lot of articles for Radio World, a magazine, a very popular tabloid magazine in the industry. And a lot of folks know you. In fact, of course, I met you early on at some radio shows, and then for some years when I was a contract engineer, and I really liked the Sign Systems brand of dial-up remote control gear to control radio transmitters. And I understand you were the distributor of that product line. So you very graciously allowed me to buy directly from you, and that helped our relationship move right along too into a business relationship. So kind of carry us from that point. You've been this popular contract engineer up in Minnesota and surrounding areas. What are you moving into now?
Well, I'm moving into Benchwork is what I'm moving into. So let's start in the beginning, though. Really, I started really as a part of a family station. Our family owned broadcast facilities, and I was the engineer for 10 years, and I realized what I really was was someone who goes out and works on multiple radio stations, not just one. So between that and where I am now, I've spent the last 42 years having a pager on my belt or a cell phone on my belt 24 hours a day, 7 days a week, 365 days a year, waiting for that call. And the calls all seem to come on Christmas, birthdays, and all of those kinds of things. And finally, I just had enough. It was time for me to stop being the guy who gets called for 50 radio stations and finally say enough is enough, and now it's time for me to work on the bench and just let someone else do this. Thank you, and good luck finding that bright young man who's going to take my place, because that's really what's needed, is someone who is young enough. I'm 64 right now. I've spent enough time doing this, and I've given up too much of my personal time. And I know that's kind of a bad way to say somebody should come into the industry, but the point is that's really how it works.
Hey, Mark, let me ask you a question about your contract engineering. I've met a lot of contract engineers around the U.S., and it seems to me that a lot of them are not able to run their business in such a way that they make a really good living. Now, there's some do. I made a decent living when I was a contract engineer, although I should have charged more of the time. But if you don't mind, I don't know if you mind or not. If you mind, tell me. Just say no. But it appears to me that you and your wife Paula were able to work your contract engineering firm in such a way that you actually did pretty well for yourselves. You have a beautiful home and you have some property, and you have had a lot of happy customers over the years. I've always thought that you handled your business in a very model way that other contract engineers should have emulated.
Well, really, it came about because of where I came from. I came from a radio station, and there it was a business, and so I learned about business working in radio. And then my wife was a professional secretary, and so she integrated very well with what I really wanted to do. So the two of us have really worked well together because of that. Interestingly enough, when we're in the office, there's no man and wife thing. It's all business. But when 5 o'clock comes, the lights go out, we go to the other floor on the house, and then it's man and wife again. Interestingly enough, it's that distinct. It really does work that way. And because of that, I think our business has really worked well.
Okay. You're going to get into telling us about making a transition out of the on-the-road contract engineering and into Benchwork. And Mark, you and I talked before the show about what we're going to talk about, and I'm looking forward to hearing you be somewhat instructive about how to do troubleshooting. But before we run into that, let's just check around here with Chris Tobin and Chris Tarr. You guys have any questions? I don't know if either of you have been contract engineers. Chris Tobin, what's your story? Have you ever done this on an independent basis, or are you always working for a station or station group?
I've worked for station groups, and I've also on the side been doing contract work on quite many occasions. A lot of it's studio and transmitters, and it keeps me current. It lets me try out ideas and do things and work with other people and get a better understanding of what's going on. But it can be daunting to keep track of the paperwork. But it's fun. But I have done contract work, and I'm looking at a couple of things over the next couple of months too.
Chris Tarr, you're in a more rural area that more closely mimics the area that Mark Persons is in. Are you called upon to do contract work? And I'm curious, could you make a full-time living at it if your current gig didn't work out for some reason?
Well, yeah, I do actually do contract engineering for stations in the area because, as you mentioned, it is rural and there aren't a lot of guys in the area. So a lot of time I don't do it. Obviously the main job comes first, but oftentimes I'll help in an emergency, or if we can schedule maintenance, things like that, then I'll come in and do that as well. Could I do it full time? Probably. But am I afraid to make the leap and leave the regular paycheck? Yeah. But several times over, I've looked at the situation and probably could, at this point, make a pretty good living doing it if I, really put my mind to it and hit the ground running. I could probably take care of it, but not quite yet. I like the steady paychecks right now.
Yeah, that was a big leap for me when I went from a full-time disc jockey and engineer at a station and said, you know what, I'm not going to have the full-time paycheck anymore. I'm going to go do contract engineering. But I had already lined up a couple of regular customers, and then it wasn't hard, at least at the time for me in the mid-1980s, to find a bunch more customers. So let's go back to Mark Persons now, because we're all going to get some instruction here on Benchwork. And Benchwork is something that I'm not sure that I always enjoyed. I like being out in the field quite a bit, and Mark says you just got a little bit tired of that, but you're awfully good at the Benchwork. You've always performed this service for people who wanted to ship you something and get it fixed. So to start us out with Benchwork and kind of lead us into your philosophy on troubleshooting.
Well, Kirk, really where I'm coming from is that I came out of the old school. Back in the old days, every radio station had an engineer. And then every radio station had test equipment. They had an audio oscillator, an oscilloscope, a distortion analyzer, all those things to do those audio proofs every year. Remember, we used to do those things? And there was an engineer on site at that time. So that was when they were required under FCC rules, and if you had any trouble, maybe the guy 30 miles down the road at the next radio station could come in and
Mark, remember I told you earlier about having to unplug your headset? Yeah. I think you got to do that. It's it's doing the thing that headsets do sometimes.
Isn't this technology wonderful? Can you hear me now?
Freaking TV show, and something as simple as a USB chipset just goes. Take it away, Mark. Go right ahead. You sound great now.
Give out too much, but the point is that I came from this old school where we always did everything in-house, and engineers would all build all their special little gadgets required to do the job because, gosh, the jock needed a push button here or a relay to do something, and it all just kind of worked out just fine. Well, now all of those engineers have gone away, and I'm still out of the old school, and I used all the old test equipment. And then what I found over the years is that I was doing bench repair when all the other old guys had retired, and now I'm the only one apparently left within hundreds of miles that knows how to open up a box and work on the inside of it. What are you seeing in other places, Chris Tobin?
I'm seeing about the same. We have the number of folks here in the New York metropolitan area that are, if you will, transmitter folks is it's dwindling. The pool is getting shallow. It's drying up. I was just talking with a friend of mine today. He's a chief engineer for 3 FMs here in town for the MS Group, and we were talking about how the number of people out there who are talented enough to work on whether it's a studio gear or especially a transmitters is becoming a very small group. And we were just reminiscing of the days when you could swing a dead cat in Times Square and probably hit dozens of engineering-type people that could do transmitter work. Not anymore today. And I'm seeing it here in the big city. I'm sure out by you guys it's probably even worse with being scattered apart, from what I can gather.
How about Chris Tarr? How about Chris Tarr?
Yeah, out here, I unfortunately, unlike you do in Times Square, we don't swing dead cats around here. But
oh, come on!
No, I'm finding the same thing. And the other thing we're finding too is with all the consolidation and things like that. You've got a guy like me who can do those things, but I've got 6 radio stations to take care of. So as much as I'd like to sit down and troubleshoot through a piece of gear, oftentimes I don't have the luxury of having the time to do that. Now, having said that, I still, when there's transmitter issues and things like that, I still take the time to work through those. But even now with newer transmitters where you're just swapping out modules, even that's becoming a lost art. But it is true. There are very few people in the area who can really sit down when there's a transmitter off the air and work through the problem and get it solved.
So, Mark, let's go back to you and your philosophy on troubleshooting. I'm sure you've got some methodologies that you've worked out over the years. How do you like to approach a box? Somebody ships you a box. I don't know, let's say it's an STL transmitter. So here you have a box that takes audio or composite into it, and it modulates it with FM and pumps it up to, does it at 950 something megahertz and amplifies it and sends it out the back, and something's wrong with it. What's your typical approach? What do you do first?
Well, first of all, you have to identify the problem. And, being a broadcast engineer, I then can understand the problem because the guy says, well, it's doing this. It sounds funny or something like that. And I'll think, oh, okay, well, maybe it's off frequency or something like that. So that's kind of where I might start. But there's more to it than that. Oh, interestingly enough, I have received and repaired and returned equipment to 11 states this year from my little office in Brainerd, Minnesota. It shows you, people just send me things, and then, of course, you send me one thing for repair, fine. They'll find 3 more things in their same facility that also need repair. And guess what? They send me those too. So where do I start? Well, again, I kind of have to understand the equipment because, gosh, I worked on that equipment before. I worked on those in the 50 stations that I worked on and the 12 new ones that I built along the way. I've seen just about every piece of gear out there.
You mentioned something that Mark, that's really key, I think. And working for the Telos company like I do, I'm responsible for helping folks get equipment fixed in other countries. So Telos and Omni and Axia gear, some under warranty and some not. And it's what we find is that, and you alluded to this, is that an engineer, a technician who is going to fix something, needs to have a grasp on what proper operation of the gear looks like. What is this box supposed to do, and would I recognize it doing its job well or properly? And so, you hand somebody a telephone hybrid who doesn't know that a hybrid is necessary to put a phone call on the air, and they're not likely to be able to recognize what the problem is or how to fix it. And you alluded to that. I think that's absolutely key to being able to fix something, is knowing what proper operation looks like. You want to talk about that?
Oh, sure. And it all comes from being a broadcast engineer in the first place. So it's the right thing. You're right. If you're not in broadcasting, how are you supposed to understand the problems of this gear? Unless you happen to be the manufacturer, and sometimes then you don't understand because you might not even speak the language involved. So it's an interesting story. Anyway, it's just second nature to me because I know that all I need to do is have a schematic, of course. Boy, isn't it nice that in the broadcast industry we have equipment with schematics, and the equipment that doesn't have schematics, really, I don't hardly touch. And I also don't touch most of the digital stuff because I really can't repair that, and that's really in the domain of the people who really work with digital. But anything analog, that's my bailiwick. It's what I do.
Well, somebody mentioned, and it kind of touches on knowing what the thing is supposed to do. One of the engineers who is one of my mentors, who kind of taught me a lot of what I do now, had a really good starting method, and you may be touching on this in a second, with knowing what it's supposed to do, and then identifying and understanding what it's not doing in order to know what to do for your first step. It's kind of like, okay, what should it be doing and what is it not doing? And once you can define those two things, a lot of times it doesn't take a whole lot of work to figure out what's wrong.
Yeah, but you could get led down the wrong trail here, and I think I've done that in the past too. So first of all, I write down on a piece of paper all the things I know about the test or about the equipment, and then I've got a test bench with all the equipment I need: voltmeters and oscilloscopes and audio oscillators, watt meters, spectrum analyzer, the whole mess. But really, a lot of problems come down to two things. One, you can see a problem just by looking inside the gear and looking for where the smoke leaked out. And that's a common thing. Tell me you haven't done that too. And the other is looking at power supplies. You could be troubleshooting a problem and trying to figure it out. And then really what it started out with was a power supply problem. The voltage wasn't right. There was hum on the supply rails or something like that. So just as a matter of standard technique, I will measure the power supplies, put a scope on them just to make sure they're where they're supposed to be, and then I'll look at the most of these devices use series voltage regulators, and so I'll look at the input voltage to the regulator and the output voltage and make sure there's plenty of extra voltage there on the input so that they can regulate properly. And then I even put them on a variable AC power supply. I've got a Sencor, and I'll bring the voltage down to, say, 105 volts AC on the input and see if a problem starts to happen, hum or buzz or something, and I'll say, well, heck, I've got a power supply problem before I even go looking for anything else.
Hey,
and so
Mark, I got a question about a technique about measuring power supplies. When I got started in engineering myself, I was always using a DC voltmeter to measure the power supplies. And, of course, I didn't, at the time, I'm self-taught in engineering and in electronics, and I missed a few times when a power supply had AC ripple on it because the DC was reading okay. Well, then I had an oscilloscope, and so I started using the oscilloscope to read voltages because that can tell you a myriad of things. Just right, is there other noise, high frequency noise? Is there oscillation going on? Is there hum? Is the DC at the right point? So using a scope can tell you all those things with just one look at the screen. But here's my question though. A friend of mine, he had a technique for using a voltmeter. First, he would measure on the DC position, and then he would put the voltmeter in the AC reading position and read it again to see if there was very much AC on a power supply line. And he said for him, that's a quick and dirty way as good as what he would have learned with an oscilloscope. Is that valid? Can you see the AC ripple using an AC voltmeter?
With some AC voltmeters, you can do that. With some AC voltmeters, it won't work. So I just use an oscilloscope. It's the right way to go because I can see whether it's 60 cycle or if it's an oscillation or what. So, and I'll even look at the ripple on the input to the voltage regulators before it gets to them, and then look at the output to see how many millivolts of ripple or noise or whatever might be on there right then. And that's so key because I can solve so many problems right at the power supply. And if you think about it, a large percentage of our problems really are power supply problems. Not that that's going to solve all of my problems, but it sure is a good start. And I just believe in that, and it works so well for me. After all, I've fixed hundreds of pieces of gear.
I would have to agree, and maybe Chris, Tarr, and Tobin have the same experience that probably 30, 40, sometimes close to 50% of my own troubleshooting experience, it did come down to the power supply. And you know, I always think, well, why is that? Why is the power supply so often the issue? Well, the power supply is in many pieces of gear, is the most stressed part of the equipment. It's taking this incoming voltage. A lot of times it's warm, it's even hot because it's doing regulation of that voltage to a smooth DC. Maybe it's several different voltages, maybe it's plus and minus voltages. So there can be a lot going on in a power supply. And I'll add one more thing before I move along on this. In so much older broadcast gear, sorry about the camera, the power supplies were good old-fashioned linear supplies with, you know, big iron in them and big capacitors and big diodes and then maybe there was a regulator or two after all that. But so many modern pieces of gear have a switch mode power supply, which I find that they're not so serviceable. To me, they seem like this big juggling balancing act inside. And unless you just see something that obviously smoked, in my opinion, they're not entirely serviceable on the bench. You might as well just swap the thing out and get a whole new one. Let me shut up now and hear from Chris Tobin and Chris Tarr real quick on that subject of power supplies, and then we'll check back in with Mark Persons. Chris Tobin?
Oh, I agree. Power supplies definitely first thing I look at, and I use a scope, Simpson 260 meter, and a Fluke DVM, and between the three combination, you can pretty much troubleshoot anything with the power supply. And lately, the switching power supplies, I've had 1, 2, 6, we had 5 fail on us on a couple of our T1 frames, and none of them were serviceable. No matter what I did, there's just no way to do it. It was cheaper just to buy the replacement module. The old linear supplies, yeah, we can fix those, and we've got a few still in operation. But I think, you know, oscilloscope is the best way to go. If you want to do any troubleshooting in any of the analog and even digital, you can do a lot with the scope. Much easier, faster, and once you get used to the waveforms and what they look like, you start to put together the patterns, go, oh, I know where this is going. And it's worked for me, and I'm sure the same is true for a lot of others.
Mr. Tarr, how about your power supply woes or successes?
Well, you know, I find nowadays a lot of devices are using very similar, they may not be physically the same, but similar internals in terms of power supplies. So I find in a lot of cases, at least with the switchers, it's a whole lot cheaper to just stock a couple of them. You know, for example, did you know that the Telos 1x6 and the 360 system use a very similar power supply? You know, and you can actually be made to work with each other. I had to learn that in emergency. So, you know, I find that, you know, a lot of times it is a lot easier to just have a couple of different power supplies, the smaller switcher, just, you know, sitting in the shop somewhere and go that route. I generally don't spend a lot of time messing with them. Although you do find, like in most gear, the first thing to go are the electrolytics, because it does get warm. The paste inside dries up, and then that's when you have problems. But that goes not only for power supplies, but generally a lot of older gear, that's usually the first to go are the electrolytics.
So let's swing back to Mark Persons now. So let's say that you've got the power supply, either verify that it's okay or you've got it fixed. Now, Mark, my own experience is that it's very rare that any piece of equipment actually has more than one problem at a time. Now, there may be some other things that are getting weak, like if you get a piece of gear that the power supply's got dried out electrolytics, you replace those. Well, you know what? There may be other electrolytic capacitors in that same piece of gear that probably ought to be replaced. But usually, if you find one problem, you've found the problem, and the gear will be returned to service. That's not always the case. But let's say you fix the power supply. Now the gear still has a problem, or you verify that it's good. Where do you go next? Let's take some typical 19-inch rack piece of gear. How do you get a feel for what the problem is next?
Well, it really depends on what the gear is. Gosh, you know, this brings up an interesting subject. I received an exciter that had been hit by lightning, BEFX50, and it came in from not Louisiana, but Missouri, I think. And after I fixed the power supplies, I had yet 9 more semiconductors that had failed. And that was a tough one, because you're right, this was a rare one where there were more than one problem in there. And it means getting out the oscilloscope and tracing waveforms from point A to point B on through the stream of what's going on. And my problem on that one was in the AFC circuit. And as you know, the AFC is a loop. So it was difficult to just even figure out what was going on, because it wasn't working in the first place. And so I had to piece by piece work my way through it, and all of that takes time. But really, most electronics is start at the beginning. A good example is an audio amplifier. You start at the audio input stage, and you work all the way out to the speaker terminals or the program output terminals, whatever it turns out to be. So just follow it through with an oscilloscope. And as far as using program audio to do that, that's almost useless. I use a tone from an audio oscillator and use an oscilloscope, because then I know where I'm at for where is the clipping occurring. Is it happening just on the positive side? Is it on the negative side? Or is it both equally on each end? And does it, you know, is it making spec or not? So, and a lot of these things just come from doing them, because I've done them before. I can see the problems that are happening. So you know, and I do exciters, mod monitors, STLs, analog audio processors. I'm really good, I think, at CRL, analog devices. But from there, we should talk about an entirely new subject, and that is building gadgets for around the radio station, but only after we're done talking about the troubleshooting part of this whole thing. Go ahead.
So let me ask you about a troubleshooting technique that is sometimes, I think, used to be taught in electronic schools. I'm not sure how many electronic schools are left now, but what is this technique called divide and conquer? And when would you use that versus following an audio from the input with a scope all the way to the output till you find the problem? What's divide and conquer?
Oh, well, let's use an audio amplifier as an example. It may have a lot of stages along the way, and they might be hard to get to with a scope or something like that. Well, you've got an audio input, and you're putting in a known tone at one end. You've got an audio output, and you put your oscilloscope over there, and you say, there's nothing coming out. So let's go to the middle of the circuit. Did the audio make it to the middle, halfway down the path? Is it okay there? And if it is okay there, then let's go to 3/4 of the way down the audio path and see if it's there. And that's dividing and conquering, rather than just by gosh and by gollying my way through it and saying, all I need is a set of semiconductors to shotgun this device so that every semiconductor is replaced. How dumb is that? Why not just use an oscilloscope to figure out where the problem is, and then replace the one bad component, which is, as you said, the most likely thing to happen.
Let me ask you about troubleshooting, something that I had a hard time understanding and getting to understand. Let's say you're using an oscilloscope to troubleshoot an audio circuit. Aren't there devices in a typical audio amplifier or some kind of audio manipulator, whether it's an audio mixer or something, that would be let's say, I think the right word would be, it's a low impedance point, maybe the input of an op amp or a transistor, where you try to make a measurement there, and it's maybe I'm using the wrong words here because I don't really understand. Maybe it's what you'd call a current input instead of a voltage input, and you actually with a scope can't see much of anything there. Tell me about that situation, and where am I making my mistake in looking for audio at a point like that where you're not going to be able to see much audio?
Well, Kirk, you have adequately described exactly what goes on. On an inverting op amp, you actually have near zero voltage at that input, and you're right, it's just about all current. So there's usually some kind of a resistor in series with that input, and then there's a feedback resistor. Anyway, the point is that it winds up to next to zero, and you're right, you could think that there's nothing going into that op amp. If you pull the op amp out of the socket and read it with your oscilloscope, you'd say, there's voltage there after all. But really, the op amp is such a contained circuit anyway that you might as well just go to the output and see if there's anything on pin 1 or 7 from an NE5533 or most op amps. And if it's not there, then why not just pop another integrated circuit in? And by the way, when I'm working on gear and an IC happens to be soldered in, I will desolder it carefully because maybe I want to reuse it. I will put a socket in there and then try a replacement device, and maybe that wasn't really the problem. So I can take the original device and plug it back into the socket, and it'll still work without having to bill the client for the new device that I would have plugged into the socket. All they're paying for is my time, and of course time is the expensive part anyway. The ICs are cheap.
You are the man. You just said that you will unsolder an IC carefully in case it's actually good, put a socket in, try that IC back. Mark, I'm not worthy. I'm not worthy. That's oh my goodness. That is actually, I've done that before, but that is tough work, and I'm just, Mark, I'm so proud of you for being careful. Clients' money.
I have plenty of help. Here's how it happens. I have a pace desoldering tool.
That's cheating.
The cheating. Yes, that's right. It's cheating. Basically, there's a vacuum pump, and it sucks the solder right out of the connection, and it's such a clever tool. It's a soldering iron with a hole in the tip, and you turn on the vacuum, and then you rotate this tool around the lead that's coming through the circuit card, and that actually wiggles it enough so that the solder really does pretty much get sucked out of the hole there. And you can get an IC out pretty fast. That's after the tool's warmed up. It takes 10 minutes to get there.
Yeah. Have you ever, I've done this in the field where I've had a circuit board where I've removed some component, a resistor or an IC or something, maybe a capacitor, And I don't have a solder-sucking soldering iron with me, and the bulb isn't getting enough going on here. And maybe my solder wick, that tends to get all cruddy in the bottom of your toolbox. So I've actually heated up the solder and then real quickly held the board up close to my mouth and blown the solder out. You ever do that? Does that work for you?
No, it cools off the connection. Maybe you had success doing it. I don't recall I ever had success doing it. But, a lot of this stuff needs to go back to the shop where the tools are. And really, that's where you take the box out of the radio station, which is what 99% of the engineers do anyway. And they send the box to someone like me, and I fix the box, and I send it back to them. So that's life in the way in broadcasting.
You've kind of touched on this, the right tools for the job. Can you pick out the bare minimum tools that you like to have to do the job? And if you can leave out a couple of expensive things or stuff you only use once in a while, somebody's doing bench work. What do you think that on broadcast gear, what do you think they ought to have right there as a minimum?
Depends on what you're repairing. Really, audio oscillator, distortion analyzer, oscilloscope, spectrum analyzer for anything RF, that really does make a lot of sense.
Yeah.
Of course, the voltmeter. And then, as I mentioned earlier, the variable AC power supply. I have an actual Sencor Z meter, which I can check capacitors with, and put voltage on them. Read capacitance first, then put voltage on them, read capacitance a second time, see if they're suffering from dielectric absorption, replace them. I've got all the capacitor values on hand, or darn near everything. And then a transistor tester, looking for and I look for leakage and gain. Don't just look for short circuits. I fix a lot of those modules from MW1 AM transmitters from Harris from the 1970s.
Classic.
Yeah.
What'd you say, Chris Tobin?
I'm sorry, that was a classic. I worked on those a lot, and transistors, the best way to troubleshoot those was checking the gain and not worrying about shorts on the junction. Okay.
And interestingly enough, I read gain and leakage, and it doesn't take much. And it just tilts the whole module out of where it's supposed to be, because a lot of in those modules is all DC coupled. So if anything looks askew, I throw the semiconductor and I put new ones in, and I even measure them, the new ones, before I put them in, because I don't make any assumptions at all. Then I'll take an ohm meter, and I'll check between the case of the transistor and the heatsink on the module. Make sure I don't have a short there. And the most logical place to get a short on that module is between one of the tip 42 transistors and ground, the one that's on the heatsink. And you'd be amazed. And I have about a 99% success rate at that point of curing the module problems before it goes back to the customer. And for those customers who want to pay the extra money, I take the module over to a local radio station and actually try it in an MW1 transmitter, charge them for the time, and then and fortunately they have a backup transmitter, so I can do all this and they don't even know what's happening, and then send them back out to them.
I was going to ask if you had to go take them off the air. Hey, when your commercial's over, let me know. I'm going to test this thing for these guys.
Oh, sure. I'm just trying to tell you how it works. And by the way, it's on my website, mwpersons.com. Everything I've told you is there.
Kirk, if I can jump in for a second, one of the things we're talking about in the IRC channel is one of the most important tools that you should have is a decent soldering iron. And for those listening to the podcast later on, I can't stress that enough. I used to think that I was just really bad at soldering things until I realized I had the wrong soldering iron. That makes all the difference in the world. I have a variable temp weller now, and it makes soldering just dead simple. So a lot of times when people are having struggles, making good solder connections and doing a good job with that, it's often because they're using the wrong soldering iron. Make sure you've got a nice variable temperature soldering iron with a nice clean tip. You have something there to keep the tip clean and tinned, and you'll have no problems doing those solder jobs.
So if you have a variable temp soldering iron, how do you choose the temperature for a given job? Would just leave it the same all the time, or you actually adjust it for different things?
Oh, you know, you absolutely adjust it depending on what you're working on. For example, surface mount devices are going to use a lot less heat than, say, you know, something inside of a transmitter, a huge joint, something like that. So definitely, it's kind of the minimum heat necessary to get the job done, because you don't want to burn up any traces or anything like that. I know a lot of guys buy them and just crank them to 11 and leave them there.
Yeah, that's why I asked the question.
One way to do that. Of course, you're wasting your money then on getting a variable temperature iron.
Yes.
But I mean, you know, I've seen a lot of guys also do that and then complain when they burn up traces on whatever board they're working on. So you know, the reason that you have the ability to adjust the temperature is so that, you know, you can turn it down, dial it down a bit when you're working on surface mount devices.
So you want to melt the solder, but not melt anything else, including whatever the adhesive is that holds traces to the circuit board.
Exactly.
Yeah. Mark, let me ask you about solder. It seems a few years ago they quit putting lead in solder. Is that right?
You know, I've heard that, and since I'm an old school guy, I've always gone for the 60-40 solder. I keep using the old stuff. I'm not so hot with the new stuff. The reason is because I did sample it one time, and I wasn't all that happy with what they're doing. So right now I'm still inhaling lead, which is a common thing that happens every day in the shop here. Oh, by the way, I use a temperature-controlled iron in the field. I believe it's a Weller. It's where the tip has a magnet in it, and behind the magnet is a switch, and it holds it at 700 degrees, that kind of thing. But the real trick in the field is a neat little thing. Instead of having like a 4-foot power cord for it, I added 6 feet to that 4 feet. I now have a 10-foot power cord on there, and it is so convenient for working in the field, which I'm not going to be doing anymore, thank you. But I'll tell you that outlets aren't within 4 feet of anything you want to solder in a studio. I can tell you that right now, or in a transmitter site as well.
So I do have one question, though. Does it tear a hole in the space-time continuum when you're soldering a soldering iron? I just was curious about that.
Soldering a soldering iron, yeah.
It's like Googling Google.
I always have people help me out by holding this, and I say, "Is it okay if I solder your fingers into the circuit along with it?" So, but I also get people in awkward positions, like holding onto a piece of equipment in a rack, and say, "Okay, hold on, I'm going out to lunch. I'll be back in an hour."
Yeah, right. Those by the way, those temperature-controlled soldering irons, the ones that have a fixed temperature based on some properties of the tip, those actually use the mechanism of the Curie point to regulate their temperature. I don't know all about what that is, but a very smart man who used to work for me told me that, and I just looked it up on Wikipedia, and it appears to be true. It has to do with changing the magnetic properties at a certain temperature, and thereby turning turning the current on and off, so it maintains the right temperature. Anybody know about that, or am I just am I smoking something?
Is that like a mutually exclusive thing, or can you be doing both?
Hey, Mark, do you have a gas-fired soldering iron?
You know, I had one of those to use in the field, and I used it so little that I threw it away.
Yeah,
I figure I've got 150 feet of power extension cable in the van, and if that isn't enough, then sorry, I'll have to bring the whole thing back into the shop someplace.
Yeah,
I have a Weller one that I actually like a lot for quick jobs because it heats up really quickly. That's the one nice thing about those. But they do have a tendency; they're kind of a pain and to wield around. And I would much rather use the electric one because it's much easier to hold. But if I need just a really quick solder job, they're great because they heat up in literally a minute.
Well, here's another tip for the field. I went to a hardware store and I picked up some copper tubing, like copper pipe, and a cap that goes on the end of it. And what I do is, when I'm done using the soldering iron, since it's it's an always-on soldering iron, it's not a solder gun, I pull the plug, and then I put the hot end of the soldering iron into this tube, and I can put it in my toolkit without damaging anything in the toolkit. So I've been described as being the guy who makes the quick getaway. by throwing the soldering iron in my toolkit, jumping in my van, and going away. But I also remind the customers when I'm doing that I have a tail light warranty. So the warranty is as good as long as they can see the tail lights on the van.
Oh, all right. Hey, we got to pause the show for a second so I can tell you about the folks who help make the show possible, and that is happens to be my employer, which is Telos Systems. Telos is a sponsor this week of This Week in Radio Tech, and I want to tell you about the Telos HX digital hybrids. And the reason this is kind of on my mind today is because I just got a report from the factory that we actually have finally sold out of our stock of the famous old Telos 1 hybrids. There are no more Telos 1, at least the modem case, hybrids to be had. We still have a few of the rack mount case. Well, the good news is that a couple of years ago, we started designing a new hybrid that we could build for less money at Telos and actually have better performance, a lot better performance than the venerable Telos 1. And that's the Telos HX1 and the dual hybrid companion to that, the Telos HX2. If you'll go to the Telos Systems website at telos-systems.com/HX, you will see all about the Telos HX hybrids. These are rack mount. They're a 19-inch rack mount, standard deal there. And you have the single hybrid, the HX1, and the dual HX2. Get whichever one you need for your purposes. If you need hybrid audio in a couple of locations, the HX2 would be what you want. Also, with the HX2, you do have the option to turn on the cross connect internally, and this means that you can send just one mix minus to both hybrids, and the callers get conferenced together from one hybrid to the other. So just one mix minus from your audio console will give you end up letting both callers hear each other and the host on the air. The Telos HX1 and, of course, the HX2 have a new chipset in them that's designed to work with POTS, that is plain old analog telephone system, all over the world. And no matter what country you're in, there is a dip switch setting for the particular requirements for loop current and voltage and ring cadence and how the phone line drops, whether it's a battery reversal or just a disconnect for a moment. There's a dip switch setting for almost every country in the world. So it'll plug right into any phone, any POTS company phone line and work properly. It also gives you some features that we've been putting in our more expensive telephone hybrids that before were not available in the lower end telephone hybrids. I'm talking about the dynamic digital EQ, for example. So the caller audio is automatically EQ'd, low, medium, and high, to try to get the best sound out of each caller. Also, the echo cancellation time is much longer now on the HX1 and HX2. So if you're taking calls from people calling from, say, a cell phone, which has a fair amount of latency in it over a digital connection, or someone calling from a voice over IP phone, or somebody's calling in using Skype out, for example, there's going to be more delay there, and there's going to be a need for a longer echo cancellation period. Well, the HX1 and HX2 have that as well. So check it out on the website. Call your favorite dealer after you've read all about them. You can download a brochure, or you can download the manual for the HX1 and HX2. telos-systems.com/HX. And just in case I didn't explain what these things do, they're for putting callers on the air and getting the best audio quality you can from an analog POTS line, from a caller calling on an analog phone or a cell phone, or from something like Skype out or a Vonage type service. So the HX1 and HX2, check them out, won't you? I appreciate it very much, and thanks to Telos for sponsoring This Week in Radio Tech. All right, moving right along. Mr. Tobin, you've been kind of quiet. You got any questions at this point? Or are you good?
No. Actually, Mark's been answering all of them, and he's touched on all the topics I would have talked about or inquired on. It's just, nowadays, troubleshooting stuff, it's becoming more and more difficult unless you really do have a shop set up and you can take advantage of the time and space to work on things. I think Mark's definitely got himself a nice little niche and is doing very well.
So Mark, okay, let's say you've troubleshot the problem, you found it. What kind of steps do you go through to verify your repair? How can you check and see if it's going to either meet the original specs or at least work well enough for the customer's needs?
Well, there is the obvious. By the way, I turned off the overhead light. Do I look any better or worse? I think I probably look worse now. I might turn that back on in a minute. Really, if you go with the instruction books for the equipment, it gives you the specs for distortion, signal to noise, power output, receiver sensitivity, whatever it turns out to be. A book is what you should have. It's amazing the number of instruction books that absolutely have disappeared from this planet. If the aliens have done anything, I think they've stolen the instruction books for equipment is what's gone on here. Really, because, and I've got a huge stock of them, and for the ones I don't have, I tell the clients they better send their book or I'm not going to be able to fix it. That's just the way it is.
What are you thinking about companies? You said you really appreciate schematics. What about there's more and more gear that may not be fixable? Hey, I was just talking about the Telos HX1 and HX2, and there's a lot of surface mount in there. I'm pretty sure I actually don't know if there's a schematic with the HX1 and 2 or not. But if there's not, it's because we're absolutely convinced that 99% of the users out there will not be able to use the schematic. I think we'd be happy to supply it to you if you need it, and if we understand you're qualified to use it. Where's equipment going to with surface mount and devices that are a bit esoteric?
Well, to be perfectly frank here, a lot of this equipment is going to a level where I can't fix it anymore. I mean, I can do the first level of surface mount that is in essence big in comparison to the later surface mount things, but go beyond that, and I have no capabilities for fixing it. I mean, I don't have specialized equipment. So you're right, but heck, there's plenty of equipment out there that's 30 years old that it seems to just love coming into my shop for repair. And equipment that old needs to come in for repair too.
Yeah, that's true. All right, so I'm sorry. Go ahead. You weren't quite finished.
No, go ahead.
Okay. All right. So schematics. The question in the chat room that went by earlier is, where do you get schematics? What if you can't get a manual? And I think the person who asked this maybe was looking at or coming from the consumer electronics world, where indeed schematics usually don't come with the gear. But with broadcast gear, traditionally speaking, schematics have come with the manual. Isn't that right?
That's correct. But you also have to remember that years ago, schematics came with consumer gear. And you're right, broadcast is probably the last vestige of where schematics are available. And again, I can't fix everything. I can fix things that I can see on a schematic, usually. And some, well, I just have to tell the customer, no, don't even send it here because I know what's involved.
There was a time when I was a contract engineer that my little shop, we were interested in being able to perform repairs and actually just replace the lasers on the Denon CD cart players. How many of you guys had those Denon CD cart players back in the 90s?
Yes.
Yeah?
I think we all did.
And I did too.
You're kind of sighing like you weren't happy about them, Mr. Tobin.
Oh, no, well, the early days, it was interesting laser alignment and the way they developed it, and then the test jigs that you could buy and plug in and attach your scope to it and try and get the proper pattern on the waveform. It was interesting. And it would last about a month if you're lucky, and then all of a sudden it would just, you go crazy. But, yeah, the early days of laser adjustments and replacements, it was fun. Made some good money with that.
So that was a piece of gear. My experience was we actually had pretty good luck with them after I kind of figured out that alignment procedure. It was in the manual, and I don't know, there's something counterintuitive about it, but I followed the directions step by step, and usually got them aligned pretty well. And I guess they'd stay in for a few months, and maybe even until the laser was nearly gone. What was the point I was making about that? Oh, yeah. Well, they supplied schematics and an alignment procedure, but you're talking about a piece of gear here that was $1,000 or more, and it was worthwhile to replace the laser. Now, when radio stations would buy a consumer CD player, something that cost $100 or $200, then and it died, I said, look, it's not worth it to replace the laser. Just replace the CD player because it's going to cost you more. Laser's going to be close to $100, and there's my time involved. Mark, how do you advise your customers on whether or not to repair something?
Well, the way it works is a piece of equipment comes in the shop, and I kind of look at it, and then I'll advise them. I'll say, I think it's going to cost this much, but I don't know where we're going. But a lot of times, or sometimes, a piece of equipment will come in, and I'll look at it and I'll say, you don't even want to try this. You just might as well just forget it. It's a piece of junk. Okay? It happens. Live with it.
Gotcha. Hey, Chris, Tarr, you had a thought about manuals.
Yeah, I was just, as you guys were talking about, having manuals on hand for things, it got me to thinking. What I do is I have my iPad here, and I'll see if I can flip it around to show you. I have a program called Goodreader, which allows you to save PDFs on your iPad. So you can kind of see that there as it gets focused. Essentially, every piece of equipment I have, and then some, I have a PDF version of the manual. And if I can't get the PDF version, I scan it, and I keep it in my iPad, and I have it with me wherever I go. And it has saved my bacon many times when I've gone out to a site, maybe not even one of mine, where there's a piece of equipment there and they didn't have the manual. Well, I did. And I mean, I have literally hundreds of equipment, different pieces of equipment. I have their manual there in my iPad, and I bring that with me wherever I go. I also obviously copy in my laptop too. But you'd be amazed how nice that is to be able to just know that you've got manuals for everything with you, especially in those nights when you haven't been cleaning or straightening up your area and you don't know where the manual is, to have one on hand. So I really do recommend, either on your computer or if you have an iPad or something like that, to get PDF scans of as many pieces of equipment as you can and have them with you, and at least the ones that you have. And a lot of times you can go to the manufacturer's websites and download PDFs for everything they have. Instruction manuals, oftentimes they will, if the manual has schematics, they'll have the schematics for the equipment as well. I know the transmitter manufacturers are great for that. So just another tip, if you're going to do a lot of running around to different transmitter sites and things like that, where you may or may not have manuals available to you, it's just a really nice, easy way to carry them with you.
Chris, you are the engineer. I mean, that is just so Star Trek-y to have all your manuals on your iPad. I mean, I was thinking of like Geordi, with some kind of tablet thing with all the manuals and how to do this and that. That's a great idea.
Honestly,
so if it's real Star Trek, does it have a female yeoman that comes to his desk?
But I mean, it is one of those things, and I've talked about this before, when you've got to manage all of these different things. When you've got 6 radio stations plus the random emergency calls and things like that, whatever you can do to make life easier for you, to make yourself operate more efficiently, not only to save your customers some money, but to save your sanity too. Because aside from the 6 transmitters and the 13 or 14 transmitters I have at 8 different sites, I've got 4 kids and a wife and all these other things to manage. So anything I can do to kind of save myself a little time and hassle is great. And that's why I came up with this idea, and it works great.
Back in my day,
for the wife and kids.
Yeah, if I could only scan them and bring them with, it'd be great.
Oh, yeah.
Wonka-vision. It's Wonka-vision.
That's right. Back in my day, we didn't need an iPad. I carried all my schematics on my Newton. Yeah, right. Oh man. So Mark, you must have quite a library there. If you've got, when I was doing contract engineering, I know I availed myself to a number of manuals, especially if the radio station had 18 ITC cart machines. Well, I'd take a manual home, add it to my collection. You got a lot of manuals there, Mark?
Yes, I do. I have a wall of manuals. It's 8 feet high, about 7 feet long, and it's like 7 or 8 rows high. Okay. And it's all instruction manuals, and I need them. I never know what's going to come in, and I love the idea of putting the manual on the iPad. It sounds like a great idea. For me, I'm going to be working in the shop. I will tell you that I have always insisted as a contract engineer that the books be kept with the equipment. How silly is it to get to a transmitter site, the transmitter's broken, and you go looking for the book. Where is the book? Oh, it's back at the studio where it's safe. Well, how good is that, huh? I mean, that's really dumb. And another thing, remote controls. Especially the sign systems remote control. you have pages and pages of programming and how you've done it. You always write that in pencil, or I always do. And it's kept where the remote control is. So if you want to make a change, the manual's right there, big deal. Boy, I can't tell you how many times I've had to call, oh, where's the book? Oh, it's here at the studio. Would you like to bring that out to me so I can work on it? Thank you. Oh, my
Well, the other thing you handle, too, when you do contract work is oftentimes they've had 2 or 3 or 4 different contract engineers before you, and along the way, the manual's disappeared, and they don't have it. The other thing I do with my iPad is I also keep all of the directions on how their remote controls work, all of the different functions and codes and everything, so that I don't have to try to remember it all or track down a sheet of paper somewhere that has all that information. So, yeah, the manuals tend to disappear. If they're not where they're supposed to be, oftentimes they're just nowhere to be found.
Here's the Kirk Harnack tip of the evening, and this is not my idea. This is the idea from my business partner at the radio stations that we own, Larry Fuss. At the transmitter site, one of the problems with keeping paper manuals at the transmitter site is just the environment. It can be moist out there, or lots of hot, dry summers, and rodents can come along and chew into manuals. So what do you do about that? Well, we just get one of those plastic banker boxes that you put file folders in, and put all the manuals in there, all the ones that will fit. And I think for us that's all of them now. They'll all fit in there, and then it locks up, a little plastic latch on it, and nothing has ever no problems have ever beset the manuals that we have that are in that plastic box at each of our transmitter sites. Works great. There's your tip of the day.
I love it. I absolutely love it. By the way, you probably know that I build a lot of little gadgets for radio stations. And where did that come from? Well, it came from things that people always needed, like an RF switch for an AM 1 kilowatt, or audio relay panels for EAS or something like that. And I always include schematics with them. Always, always, always. And then, of course, I provide more schematics when they lose their schematics. So that's just the way life is.
Guys, we're going to have to wrap the show up pretty well. But, Mark, I want to swing back to you right now and have you give us any of your last thoughts on the subject of troubleshooting and repair. We went through a few items there. Did we leave something important out that you want to make sure that our listeners are aware of?
Well, I think we've pretty well covered it. You really need to know when to take a piece of equipment to the shop. Just because it's working and it might not be working right, maybe it's time to really send it to the shop anyway, to have it checked out, just because it's the right thing, because you know that there's going to be more troubles in the future if you don't. But like I say, I think we've pretty well talked it through. There comes a limit when you're working out in the field, is how much you can repair there and how much is required to go back to the shop. And so you really have to be able to make that decision too. Although most young guys today will make that decision sometimes way too early. They might not even check for a blown fuse. I remember getting equipment in. It's just a bad fuse. Oh, I didn't know. Look for that. Oh, gosh, give me a break, huh?
Yeah, look for the obvious stuff. You're absolutely right, and a lot of that just comes from experience and or thinking about it, not walking through life and just taking the tour, so to speak, but thinking about what the symptoms are, what's going on. The fuse is blown, or is it plugged in? Just plugged in. Yes. Okay. Well, good. Hey, Chris Tarr,
I think we've had a wonderful time tonight, and I'd love to do this again with you too.
We'd love for you too. And hold that thought, Marcus. When we come back around to you, I think you may have a little joke or a story for us or something quick. Chris Tarr, huh?
You had a story. You had a story about the royal couple.
Oh, that's your story. I'm not telling that. That's your story.
Well, I have to tell that story.
Yeah, you have to tell that story.
Turns out the royal couple had their first big argument the other day. You were telling me.
What? They had their first big argument? Tell me more, Mark.
Right.
You tell.
That's right. He forgot to put the seat down on the throne.
Nice. Oh, you're a great crowd. Try the veal, tip your wife.
Oh. Should I be embarrassed to laugh at that?
I will tell you that I think my wife's telephone number is confused with that of the phone number for the Coast Guard.
Really?
And
Why would that be? What makes you think that?
I know this because I picked up her telephone the other day, and a voice on the other end of the line said, "Is the coast clear?" So I figured it's the Coast Guard.
You live in Minnesota.
You gotta love engineering humor.
That's right.
All right, hey, Mr. Tarr, any last comments? We got to jump out of here.
The only thing I would like to add is I can tell you from experience that going through the troubleshooting steps and repairing gear is very, very rewarding. I'll tell you, there's nothing quite like sitting down quietly with your test gear, going through a piece of equipment that was dead and making it alive again. And it's something that everybody should try. It's fantastic.
Mr. Tobin, how about you on the subject of troubleshooting?
Troubleshooting, if you're at the transmitter site, be sure to set up a plan to have somebody call you if you're by yourself so that you're not left there looking for assistance if something should go wrong. Always practice safety. I had too many people I've talked to that work on transmitters, and it's very dangerous by yourself. If you're not, if you're two-person out there, then perfect. If not, arrange with the studio to call every half hour, every 15 minutes just to make sure you're still breathing. I know it seems crazy, but I've talked to people that have been troubled.
It's great. Great idea. Great idea. I wonder does that ever bother you when they call you every half hour? Yes, I'm still breathing. Yes, I'm fine. I'm just in the middle of it now.
The hard part is getting the jock to do that, to call you.
Yeah, that's right. Yeah. Yeah.
I sometimes call them to remind them.
You haven't called me in 2 hours. I could be dead out here.
You send me no flowers. You don't call.
That's right. Hey, Mark Persons, thank you so much for joining us from Brainerd, Minnesota. Mark, do you want to mention anything about your service? Do you want to add, are you looking for more business? I think not, but you're welcome to mention how folks can reach you.
Oh, well, it's mwpersons.com, mwpersons.com. And really, it's all there on the website. There are a couple hundred pages there. I enjoy writing for the web. And there's a lot of tech tips. And then there's the engineer's log. It tells what's going on. And I haven't gotten to the point of putting on there about me not doing any field work because I haven't talked to all of my clients about it yet. Since I take care of 50 transmitters, I'm kind of early on into this week of trying to call everyone and tell everyone what's going on. All but one of my clients was congratulatory to me, telling me that, yes, I think you're doing the right thing. One guy didn't congratulate me. He felt it was kind of, I suppose he felt it was kind of a personal insult that all of a sudden I can't help him anymore, so now I'm no good anymore or something like that. But anyway, I enjoy what I do. I feel that I can be very valuable in the shop, doing things that engineers can't do in the field. I even build coaxial cables and solder the connectors on. I'm big on soldering connectors on. I really am.
Sure.
But that's just me. I just come from the old school. It just the way things are for me. So anyway, I'm doing repairs, and I'm still doing Econco tubes for customers. We're an Econco dealer. I've just tried to do too many things in the past, and now it's time for me to do just what I do, which is work in the shop and building things. I think I built 4 gadgets this week to go out to clients, and I hardly have time to go out in the field anymore because I keep getting orders or repair orders or something, and so this is where I belong.
Good deal. Well, Mark, I hope it works out quite well for you, and I'd really appreciate it if you would continue to write and to share your knowledge through this podcast and any other way that you can, because you do have a wealth of knowledge that would be very appreciated by people who are trying to step into your shoes. And let's just hope that there are some out there who are trying to do that. Hey, we really got to go. We're past our time. I want to say hello and goodbye to everybody. Chris Tarr, thanks for joining us from Mukwonago, Wisconsin.
Thanks for having me.
All right. And Chris Tobin from New York City. Thanks for being here.
No problem. Thanks, everybody, and enjoy a good ale responsibly.
That's right. Responsibly. Go to bed now. And Mark Persons, thank you for joining us as well. We sure appreciate you being here.
Glad to be here, and I look forward to the next visit.
All right, we do too. Hey, thank you for joining us for This Week in Radio Tech. Our show's been brought to you by telos-systems.com and the new HX1 and HX2 telephone hybrids. They can make your callers sound great. Check them out. And thanks very much to Burke and Jeff it takes two of them to switch this crazy show now at the Twit Brick House. So thanks very much for doing that for us. We certainly appreciate you. Well, you can check out the show. You can always find it at twit.tv/twert. And get the latest episodes, the audio and video downloads, and subscribe there. We're still posting links to the audio shows at thisweekinradiotech.com. So you can check it out there, too. Thanks for joining us. We'll see you next week on This Week in Radio Tech. Bye-bye.